All right, everyone. Now we're going to look at a fun topic, I think, and that is how do you read and write data to a hard drive or a USB drive or to a network drive or something. This is a really, really valuable skill. And I'm going to show you the traditional way I do it, and then I'm going to show you another little update that we can do now in the .NET framework that makes it even more cool. So here's a little demonstration program that I have, and you can see I have a bunch of items over here in a list box, and these are being loaded in the list box from a text file that I made as part of my project that's on the hard drive. So they're not coming from design time, they're not in code anywhere. And if I clear them and hit reload, it goes out to the hard drive and grabs them again, and you can see it does it super fast. Okay, I can add a new item, so let me show you that. I'll just start with A so it'll show up in front, and then if I don't want that, I can always delete it. And there's a thing says, you sure you want to delete it? I'll say no. But the cool thing about this is now that we have a list in our list box like this where we've added and deleted items, we've done that before, but the thing we haven't been able to do is to save those items back to disk. So when I save them back to disk and it says everything's fine, they were updated, and I clear my list and go back and reload it, what it's doing, it went out to the hard drive again and it reloaded the list. And now you see that that item is there. And if I want to delete it this time, I can say yes, hit save. It will update it very quickly, clear, and reload. Okay? Now, one thing to notice before we look at the code in terms of how this behaves. When the program first starts up, it goes out to the hard drive and it loads my list box. You'll also notice that when I clear them out, whacks them all, and I hit reload, it goes out to the hard drive and loads them. So I'm using that block of code to read from the hard drive from two different places. So because of that, the code that reads from the hard drive is in its own custom method, which I've showed you in some little previous videos, okay? Because you never want to have the same code in two different places at the same time that are identical. If you need to call a block of code more than twice, or more than once rather, you should put it off in its own little place, and then you can call it whenever you want. So now I'm going to quit this little pup, and I'm going to show you how this works. The first thing we're going to do is, remember, keep this is just a one form application. First thing I'm going to show you is how to add a text file to your project so that you can keep track of your inventory. And you'll notice I have it over here. It's called inventory.txt. And you see I just added some stuff from my pretend train store. How do you do it? Well, you right click on your project and you say add new item, and you come down here a little ways and you'll see something that says text file, and you give it a name. Again, I called my inventory.txt. Leave it with a txt extension so it won't try to do something weird with it. And then you add it there. I didn't bother sorting it because the list box will sort. Okay? Now, in order to read and write to the hard drive, we have to add a feature to our application that doesn't come with our standard template. So when we come in here to these using statements, I just left all the ones that were there, but what you have to do is you must add this new one, system.io, before you can do any reading or writing. So would you make a note, the system.io is for reading and writing to a file, and IO stands for input output. So this is the one that you're going to need. This allows you to create a file, check if a file exists, and read and write from it, because all the tools to do that are inside there. So once I've done that, then I can come in here and do this. Now, the first thing I wanted to do before I got into the main part of my application is I wanted to create some module or class level variables here so that I can access them anywhere in my project. And I had a couple of them here commented out because I wanted to show you what options you have. First thing you have to do at some point, you have to tell C# where is this inventory text file. And I'm going to review something here that I told you before, but bears repeating. When you build an app in Visual Studio, the default folder is inside something called the bin debug folder. Now, bin stands for binary, so you have a folder for debug, and you see this right here, this using streams.exe, that is my assembly. This is the file that you could give somebody so that they can run your app on their computer. and all they need is a .NET framework. They don't need Visual Studio, they don't need C#, all they need is a .NET framework. Now, the problem with this is the file that I'm using is over here at a different level. It's at the same level as my forms are, and I'm going to try to open this up so you can see this. So I have to tell the computer, I need you to move up to the debug folder and then to the bin folder. And once you're at this level of access to these files and folders, then it will be able to see this. So these are nested. So these guys are all nested under debug, and debug's nested under bin, and the bin folder is part of our project. So in order to move up, we have to tell the computer move back 2 levels. This has been the way we've done this ever since Microsoft created the first version of DOS back in 1981. So this is not just a Windows thing. This is the way the operating system works. So you have to tell it to move back up. If I was to take this inventory file and stick it in the debug folder, then it would find it, because this is where it's looking for, because when you run your app, this is what it's executing. That's the MSIL file. All right, now here's how you do it. You got some options. We got to come back up 2 levels. So you can say my disk file, make it a string variable, is equal to dot dot backslash backslash dot dot backslash. This syntax here says move up 1 level, move up another level, because I had to move up 2 levels, and then you'll find this, and it works just great. I commented it out because maybe you want to do this other thing. You can say the disk file equals, and you can use an @ symbol. That's the Shift 2 on your keyboard. And then guess what? You can just use 1 backslash, which is what we use in Visual Basic. So it looks maybe a little cleaner, but that's one other acceptable way. The very cool way is to do this. I'll talk to you about, you've seen this before, you know what that is, a constant for my message boxes. The really cool way is to let Visual Studio store it in a resource file. Now, what I'm talking about here is if you want to do resource file, you double click on your properties. You often have looked at this application part where you can see what the namespace is and the name of your assembly. You pick the .NET framework. There's all kinds of other things you can do in here, but if you go to resources, you can add a new resource right here. And I called my resource my inventory file. The value was, I just put that string in there. So I'm showing it to go back up 2 levels. See how that is? Now that's going to be stored with my project in what's called a resource file. They're very clean, they're very nice, they're worth doing, I think. And the way you get it out is you say the disk file name is going to be using streams, because that's the name of my namespace, using streams dot properties dot resources dot my inventory file. That's what I called it right there. And when you do that, this value disk file is going to hold the location and the path of my disk file. Okay, very cool. So between these 3 options, you pick one that makes sense to you. Now, in order to read a file, we're going to use something called a stream reader object. It comes from the stream reader class. I'm going to go ahead and tell the computer I'm going to use one right here, and I'm going to refer to it at SR. That's going to be my variable name. But I'm not going to instantiate it here. I'm not using the new keyword, so we're not creating a new object from it. I just want to be able to access it from anywhere in my form, so I'm declaring it here. I'm not creating it. Same thing with a thing called the stream writer. That's the thing that's going to save stuff out to the file. Stream reader, stream writer, they are part of the file IO namespace. This guy up here, the system IO namespace, and so if you forget this namespace, you won't see these. And the constructor doing nothing special, so that's just going to initialize my form as usual. Now let's look at the form load event, because remember I told you I'm loading the list box from 2 places, when the form loads and also when they click on the do reload button. And I did that reload button just for a demo for you. You'd probably never do something like that. So I created my own little custom method called do reload. So I just typed in private void do reload. I'm not passing in any arguments, so I didn't create a parameter here. I just put in the 2 rounded parentheses, which you have to do. And then you'll have a beginning curly brace and an ending curly brace for the method down here. All right. And again, you just find some blank space in your project code area and then just type this in. So this is a very simple one. So what happens is when the form loads right here, when line 63 executes, it's going to come down here and it's going to call or branch or jump down here and execute all this code. When it's finished running this method, it will come back up here to see if there's anything more to do. Well, there isn't, and therefore it will just display the form. So remember, anything in this form load event will execute before the form is visible. That's why when I run the app, the list box is already filled when you see it. Now let's go see what do reload does. The first thing I'm going to do is, and I did this because I wanted to show you, you can ask the user, hey, I don't have an inventory file in there for you. Do you want me to create one? And I did it because I want you to see how you can do this. So inside the IO namespace, you have a whole bunch of classes, and one of them is called the file class. And I can say if file exists, and pass it in the name of the disk file that we just made. If it's false, if file exists equals false, that means it doesn't exist. And then I can put a message box that says, hey, I can't find it. Do you want me to create it for you? Yes or no. If they do, then we're going to say file create. So that's how you create a file on your hard drive. Okay? And you would give it that name and that path. Otherwise, just set the focus to the new item so that they can put in a new item if they want to. All right, so you'll notice that I have an if block nested inside of this first if. So if this is false, then it will go around here and it'll ask him these questions. If this is true, if it already exists, then it's not going to even look at any of this junk. It's going to come down here and it's going to clear my list box so I don't have duplicates. It's going to use the stream reader to read all the lines in the file. It's going to put each line in this little temporary string. And while there's things in the file to read, it's going to read a line. The stream reader is going to read a line, and every line that it reads is going to put it in here. So it reads a line, throws it in here, and then we're going to take that item that it just read from that line and add it to the items collection in the list box, and then it's going to come down here with my logic loop and it's going to run again. And as long as there's stuff in there to read, this loop will just go round and round and round and round, read all the items. When there's nothing left to read, then it just quits. Okay, now I'm going to come back and explain what these little hoochies are in just a second, but I want to just point out something. The first thing you should notice is, Ron, what is that try catch stuff? Well, when I first saw the try catch thing, I was very perplexed by it because the word try didn't make me feel real confident. That was like, geez, you know, why are we trying something that sounds like it might blow up or something? Well, it's part of something called structured error handling, and I want you to always, 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 always use it whenever you anticipate there could be an error. And anytime you do file I/O, there's always a chance for error because a file could not be found, the disk may be broke, there may be something corrupt in the file, and you have to be able to handle that without your program just blowing up. So what you do is you take code that you think might be a problem or where there might be an error, and you put it inside of what's called a try block. And the try block is just made by typing in the word try, and then you have to use a beginning and an ending curly brace to put it in there. Now the try just simply means, hey, we're going to run this baby. Now if there's an error anywhere in this block, if any of these things cause a problem, it's going to stop what it's doing and it's going to jump down here into what is called a catch block. This is where it's going to catch your error. So this is like something called structured error handling, and that's what we're doing. We're trapping errors, and we're anticipating possible errors. If there's an error, I'm going to put up a message box to say an error occurred while reading, and I'm going to concatenate the message that Windows gives back to me so that if someone is in Boston and they're trying to figure out what's wrong with my app, I will tell them on the phone, read me exactly what it says, and maybe it'll give me a clue as to why it's not working. After they click OK, then we just simply close the app because there's no point in going on. Okay? Now let me go back and kind of explain what this try catch is before I go in and tell you what these things are. Let me just show you a couple slides because that's probably the easiest way to do it. We're going to look at structured error handling. So on your notes, make make some good notes here for structured error handling. Anytime you see the words try, catch, finally, you're using structured error handling, okay? And you'll see it a lot. And you can use it for things other than file I/O. Now here's the simplest one. If you have a try block like I have here, then you must have a catch. That's the simplest thing. Now in this try block, I'm just going to read from my file. I'm going to read a line. If there's any problem reading, it's going to drop down here into this catch, and it's going to put a message box and show the message. Now I want to say something about the catch. First of all, you can have more than one catch. You can have one try, you can have 15 catches if you want. There are lots and lots of errors that you can trap. I could trap file not found. I could say there was a problem reading through the network. There's a million things, but you guys, I've never figured out a good reason to go to all that trouble. What I do is I catch every possible error there is, and I do that by just simply saying catch, exception, and then I usually use a little variable called EX, and sometimes I use E. Make a note, exception equals error. In the operating system world, an exception is an error. So this is going to trap any error. So if you see something like this on a quiz or a test, and I ask you what kind of errors I'm trapping, the answer is everything, all possible errors. And then in my message box, I can just use this little EX variable and say ex.message, and this all comes up in IntelliSense, convert it to a string, and it'll show up in the message box, and you can see what happened. File not found, something like that. Okay, so again, the simplest way, one try, one catch. For every try, you have to have one catch, but you can have multiple catches. All right, let's look at the other thing I was just telling you. Here's an example of having two catches. One is file not found exception. Here's another one, I/O exception. I/O exception means there's something wrong even reaching the hard drive. This one I could reach the hard drive, but I can't find the file. So in this case, I would say the file wasn't found. This one says an error occurred while reading. Again, I just combine all of them together in one because that seems like a simple thing to do. Okay? Now on the last slide, there's another section called a finally block. Write down a couple things. A finally block is optional. I strongly recommend it when you're using this way of doing file I/O. Strongly recommend it because any code you put in the finally block will execute whether or not there is an error or not. I'm going to say that again. Any code you put in the finally block, even though it's optional, will execute whether there's an error or not. So here's why I like it. Up here I created a new stream reader and it opened my file. You don't have to tell it to, but it does it. And then it's going to start reading. If there's a problem, it's going to come down here and do this. But when everything is said and done, before my method ends, it's going to come down here and it's going to close my reader. And it's incredibly important that you close files correctly, because if you don't, you may never open them again. You don't want that to happen. Okay, so when we're coding like this, I strongly urge you to use the finally block, because this will close the file whether or not there's an error or not. It saves you from typing it up here and then down in here. You don't want to do that. Again, you don't want to repeat yourself in code, because you'll forget one of those. If you go back and change one, you won't fix the other one. All right, so that's the bit with try catch. Now let me go back here and explain to you what this mess is. First of all, I come in here and I clear my text box, or my list box rather, because I don't want a bunch of duplicates. If I don't do that, it's just going to keep adding to the list box. I'm going to have a million of the same thing. Then what I want to do is I finally want to create my stream reader object so I can read the file. I declared it up here as SR. That's very common. Coders use SR for the reader and use SW for the writer. The reader is going to read, the writer is going to save. Okay? So I come in here on line 87 and I say, hey, SR is going to be equal to a new stream reader. Anytime you see the word new, that means I'm creating a new instance of this class, stream reader class. I'm making a new object. And you can't use a stream reader until you instantiate it, make a new object, so we can access all its capabilities. One of the things that the stream reader class has is it has multiple constructors in its class. Now remember, we didn't write that, Microsoft did. And one of the constructors will allow you to pass in the name of the file you want it to open. That's very, very handy. So as soon as stream reader is created, it also will go out and open the file so we can read from it. Notice I don't have to say open the file, read from it, nothing. I just have to say open, I just have to create it. And then what I do is I create a little scratch variable, and I call it a scratch variable because it's only used for a few thousandths of a second typically. And I name it data from file, so I know this is the line of data coming from the hard drive. I put it inside of a logic loop. Here's our while loop again, and it's a pre-tested loop. Remember I went through all the drama of telling you about that. And what we're going to do is inside this loop, I'm going to say, stream reader, I want you to read a line. Now read a line will read the entire line, whether there's a comma in it, whether there's punctuation in it or not. It reads the whole thing. As soon as it reads it, it throws it into this variable for just a few millionths of a second. And then the next line takes that data from that variable and adds it to the items collection of this list box, and then the loop continues and goes around again as long as there's something to read. How does it know something to read? Well, let's look at this. The stream reader has a method called peek, and you can tell it's a method because it has two little doodads there, and it does sound like a verb, it does sound like action. And I want you to write down it saying if there's, and what this does is this peeks into the file, it looks into the file and it sees if there's anything else to read or have we gotten to the end. If there's nothing to read or it has gotten to the end, peek will return -1. So in your notes put down if sr.peek, if the stream reader finds that it returns a value of -1, that means nothing left to read. It's just like with the list box, if the selected index is -1, that means they didn't pick anything. So it's the same idea. Okay, so sr peek not equal to -1. Okay, so if it's not equal to -1, that means there is something in there. I know it's backward logic. So if there's something in there, go ahead and read it. And keep doing this over and over and over again until there's nothing else to read. That's why the logic loop here is so handy, because with a for loop I had no idea how many items are in that list. But this guy will just keep reading as long as there's stuff to read. Now the reason that I used a while loop and not a do loop here is because what if there's nothing in the file when it first tries to read it? What if it can't open the file right? There's no reason to try to go on and try to read something that isn't there. So I always use a pre-tested loop here to make sure there's something to read. So this loop may never run. There's no guarantee it'll run at all. It'll only run if there's something in there to read. Okay, very important to understand how that works. All right, and then if there's an error anywhere in this try block here, it'll stop what it's doing and it comes down here with the exception block. And then finally, the finally block that I put in will close my stream reader whether there's an error or not. That's why I like using that. Okay, so there's a good example of using that. Now the button reload button, it just runs that same code. So that's why I did it. I have two places that I need to read the disk file. One in the button that says reload and once in the form load event. That's why I put this off in its own little section so I could call it when I wanted to. Now I don't think there's anything else in here particular. Well, yes there is. Never mind. If we're going to add a new item like I showed you, we're going to take the item from that new item text box, put it in this little variable, and then I'm going to add it to the list box just like we've done. The thing we haven't done before, of course, is to update our list box and save it back to the hard drive so that we can update our inventory. So let's do that now. In this try catch, I'm going to create a new stream writer, and I'm going to pass in the name of the file that I want to write to. But this time when you're writing, you have an option. You can either say I want to take what's in there and get rid of it and start clean to overwrite it, or I want to just append to what's already there. Well, I don't want to append because again I don't want duplicates. If you don't want duplicates after this comma, you put in false, and that's why I made a note there for you. False means don't append. If you want to append, you put true. So this stream writer is going to go ahead and open up this file just like the reader did. But look what we're going to do. We're going to go the opposite way now. We're going to cycle through all the items in the list box using a for each loop because the items in a list box are a collection, and I told you that that's what the for each loop is good at. So I'm just going to cycle through all the items in the items collection inside of this list box. So we just say, I'm going to create a new variable called my item. It's going to be a string, and we're going to cycle through all the items in the items collection for this list box. Okay, and then for each item it comes to, I just want it to write it out to the text file using the stream writer. So I'm going to say streamwriter.writeLine. So just write the whole line. It's going to take the first item, write a line. It'll do a carriage return line feed. It'll put the next one on the next line. So every item comes out on its own line. When we're done cycling through the list box like this, I'm going to put up a nice friendly message that says, hey, your data's been updated, everything's cool. And again, if there's a problem, the catch block will handle that, and I just put out another message that says I couldn't save your changes, and then have an error icon. Okay, and then again, with the finally block, I close Mr. Streamwriter, and that way everything is copacetic and we'll be able to read and write it again. The only thing left here is when we clear items, this is how you clear the items in a list box. Now it doesn't delete them on the hard drive, it just clears them out. And then if you want to delete an item from the list box, I'm going to say, hey, you sure you want to delete this item? And I append its name. If they say yes, then we're going to say the name of the list box.items.remove, take the selected item and whack it. And then the exit button does what you expect, and that's kind of what that feature has. Okay, so make sure you do some reading on try-catch. Make sure you download this and look at it. Make sure you build one yourself so you understand how it works, because there's a lot of pieces and parts to this to make it work correctly. Now, just to finish the story, I want to show you the new cool way to do this using exactly the same project. And the code is almost identical except for one thing. And let me show you that. This is the new way of working with stream readers and stream writers. Before, I came in here and I said I had to make a new stream reader. Look at this. A few years ago, C# took an idea from Visual Basic, and they used what's called a using statement. Now, the first time you look at that, it gets confusing because they use it for this, for namespaces, but now they're using it for this down here. And you can use this using thing for more than just a stream reader, but here's what it does. It says, hey, I'm going to be using this object called a stream reader. It goes ahead and creates it just like I did, right? But here's the nice thing about the using strategy. When you build this, it goes ahead and creates this, it opens a file, and when it's all done reading, you guys, when this block of code is finished, the stream reader will automatically close my file, and it will tell the garbage collector, which gets rid of all the things in memory that we're not using, hey, you can get rid of stream reader now. We're not going to use it anymore. So when you're using this kind of new technique with the using bit, you don't need a finally block. You don't have to worry about closing your file because this guy will do it all for you. You just have to try to remember that it has to be inside of its own parentheses, just like for, just like while, just like for each. Okay, kind of the same thing. And no semicolons after them because you're not telling it to actually do anything. You're just creating something and evaluating stuff. All the rest of this is the same. We do the same thing with stream writer. I come down here and I say I'm going to be using a new stream writer. Go ahead and create it for me. No appending. All this is identical. I'm using my loop to read it back and rock and roll. When this is finished, when the try block is finished, it's going to close my file for me automatically. It will dispose of my writer, this guy here, remove it from memory so I don't waste my memory, and we're good to go. So this is the new technique that you probably want to use, and you can use this for lots of things, not just file I/O. You can use it for lots of things. As you do more complicated and sophisticated programming, especially doing phone apps and stuff, you'll be using this a whole lot. So I wanted to show you both of those. I will put both of them on the website for you, and I'll make an indication for you that this is using the new using format. But other than that, the thing is identical. I just copied it and copied all the code and just put that in there for you. Okay, so even though this was a little longer than I anticipated, this is a really nice collection of information for you on doing file I/O in C#, and so I would strongly encourage you to read on it, look it up, build one of these, and listen to this as many times as you need to get a hang of it, because it's really a fun thing to be able to do, to be able to update your data. All right, guys.